What is g at the height of the space station 3.5 times 10 to the 5th meters, which is above the surface of the Earth, whose radius is 6.4 times 10 to the 6th meters? So if we write down the acceleration of gravity first at the surface, we would have GE is equal to GM over R squared. Now if we go for our space station, who's at a height h above the surface of the Earth, we would have G times M over R plus H, the entire thing squared. Now, by simply plugging in a value for R plus H squared, this is not going to help to give us a form for what our gravity at the height is going to be in terms of our surface gravity. Because if we just plug in this value into here, and would actually calculate that out, we would find that GH is equal to G times M over some quantity. But then we have to relate it to the acceleration on the surface of the Earth. Now, instead of doing that, say if we were to divide these two equations by each other. So if we have GH over GE, same as GM over R plus H squared. Now, since we're dividing by the acceleration of gravity on the surface of the Earth, we're dividing by a fraction, we multiply by the reciprocal. The reciprocal of the gravitational constant times the mass over the radius squared is the radius squared over the gravitational constant times the mass. Now, in this equation here, the gravitational constant for each of these is the same, and the mass is the same. It's both for the planet Earth. So when we multiply G times M and then divide it by G times M, this is simply just going to cancel out and give you a value of 1. So what we're left with is GH over GE is equal to R squared over R plus H squared. Now if we solve this for our acceleration at our height, which would be GH is equal to GE times R squared over R plus H squared. From here now we can see that we can have a relation between our acceleration at our height to our acceleration at the surface, which we know, based off of simply just the distances now. We don't have to take into account the mass or the gravitational constant. So now if we just plug in the values that we are given, that we've already know. So the radius of our planet is 6.4 times 10 to the 6th meters, and we know that we're at a extra added height of 3.5 times 10 to the 5th meters, which is the same as 0.35 times 10 to the 6th meters. So our total distance between the center of the planet to the object, which our space station at a certain height, would be 6.75 times 10 to the 6 meters. And we square that. Now if we square these two, then divide, we would get a value of 0.9 times the acceleration of gravity at the surface of the Earth. So our answer would be E, 0.90 g on Earth.